An Introduction to the Windows of Laser and Optical Simulation Software LASCAD. Part 3. By Amin101h. Laser Engineer and LASCAD Sales Manager. Multiple LASCAD windows in one frame. By clicking on the choice 2D data profiles and parabolic fit, you can achieve to 2D data profiles at different positions along the z-axis. Click Refresh and Fit, in the frame Parabolic Fit, to carry through the parabolic fit. The red lines represent the parabolic curves, and the blue lines the FEA results, respectively. The good overlap of both lines is showing that the temperature distribution computed by FEA is very close to a parabolic curve in the present case. After carrying through the parabolic fit, the focal length of the thermal lens is shown at the bottom of the window. It is measured as distance from the left or right principal plane of the thermal lens, respectively. In this window, LASCAD shows 3D plots of the FEA results. For example, 3D plots of heat load, temperature distribution and stress intensity are in access. One important point is that you can see laser diode pumping effects on rod in this window. So, if you had a wrong place setting of diodes, you can see your mistake here. If you select Laser Power CW, in the main LASCAD window, you can open the window Laser Power Output. Laser power output can be computed for single and multi-mode operation. By selecting the option, Use Output Mirror Reflectivity, it can plot the laser power output as a function of the output mirror reflectivity. Some cases like account for apertures, multi-mode operation and pulsed operation can be considered here according to parameter field window data. LASCAD provides several tools to analyze the properties of the cavity that you can see them in tab view in main menu window. Some properties of a laser cavity like stability of laser resonator and transverse Gaussian mode profile are here that you can analyze and watch them. The capability to create a plot showing the transverse pump profile, together with the profiles of transverse laser modes, can help you to see beam overlapping. The tab Dynamic Multimode Analysis, DMA code, is used to analyze multimode and Q-switch operation of lasers. In this code, a time-dependent analysis of mode competition effects and multimode behavior of the cavity is obtained that is used to compute beam quality and laser power output, and to describe time dependence of Q-switch operation. Type of Gaussian modes, Hermite or Laguerre Gaussian modes, CW, or Q-switching operation, mode of pumping and all kind of apertures help you to achieve the results. After running DMA code, you will find some features like pulse shape and time-dependent power output for Q-switched lasers with high repetition rates, as well as for single pulse operation, individual power output of transverse modes for CW and Q-switched operation, beam quality M superscript 2 for CW and Q-switched operation, effect of hard-edged and Gaussian apertures on beam quality and 3D beam profiles in the crystal. By clicking BPM/Run BPM in the menu bar of the main window of LASCAD, you can reach to some features like output power, conversion efficiency, intensity 3D profile at right mirror and changing beam radius, beam quality and laser power versus cavity iteration by the use of a Fox and Lie-type iterative round-trip procedure. In the BPM code, FEA results can be used as input for a physical optics code. This code provides full 3D simulation of the interaction of a wavefront propagating through the crystal. It takes into account the distribution of the local refractive index, as well as the deformed end faces of the crystal, as obtained by FEA.